So let's just talk about the min stack. So the min stack is a stack and it is used to retrieve the minimum element in constant O1 time. And alongside also we can perform other stack operations, like we can perform the push, we can perform the pop, we can perform the pick operation, and so on. So let's just take a look at the approach behind the min stack. So here we need to maintain two stacks. One is the main stack, which will store all the elements, and another is the min stack, where we have to store the minimum value at each level. So here we need to have the main stack and we need to have the min stack. So this is our main stack and this is the min stack. Now whenever we push a value into the stack, we have to push that in the main stack and we have to push the minimum value into the min stack. So suppose we wanted to push the value 5 into the stack. So first of all we have to push that value in the main stack. So we're gonna push this here, but we have to push the minimum value into the min stack. So the minimum of this value and the minStack.top. So because the min stack is currently empty, so we're gonna push this value in the min stack also. So here we're gonna push the value 5. Now let's just push another value. So we're gonna push this value to in the main stack. Now we have to find the minimum of the value 2 and the minStack.top value, which is 5. So the minimum of them is the value 2. So we're gonna push this value 2 in the min stack because this is the minimum value in that level. So similarly we can push another value. So we're gonna push this directly in the main stack. Now we have to find the minimum of the value 8 and the minStack.top. So the minimum of 8 and 2 is the value 2. So we're gonna push this in the min stack. So this way we can push the value 1 also. So 1 will be pushed in the main stack. Now in the min stack we have to find the minimum of the value 1 and the 2. So the minimum of them is the 1. So we're gonna store the value 1 in the min stack. So this way the min stack will track the minimum value at each level. Now whenever we perform the pop operation, we're just gonna simply pop the value from both the stacks. So suppose you are performing the pop operation, so we're gonna pop the value from the main stack. So that means we're gonna remove this value and also we're gonna remove this value also. But in case of the getMin, we're gonna return the minStack.top value. That means whenever we call the function getMin, we're just gonna simply return the minStack.top value. So these values are popped, removed from the stack. So currently this is the minStack.top value. So we have to return this. So the min stack basically tracks the minimum value at each level, so that whenever we call this getMin function, we can get the minimum element in constant time. So here is our code. So this is the main stack, which will store all the values, and this is the min stack, which will store only the minimum value at each level. And also we have this top pointer, which is initially pointing to -1. So here we have the different stack operations. So first of all we have the push. So whenever we perform the push operation, first of all we're gonna check. So here we're gonna check if the stack is full or not. So in case the stack is full, then we're gonna print stack overflow. Otherwise we're gonna store the value in our main stack, and then we have to find the minimum value to store in the min stack. So in case the top is 0, that means if the top is pointing to this first element, that means our min stack is empty. So in that case we're just gonna simply put that value into our min stack. Otherwise if we have previously values in our min stack, in that case, so we're gonna compare the value x and the value at the top of the min stack, and we're gonna return the minimum of those two values, and we're gonna store that value into our min stack. So this is the push operation. Now in case of the pop operation, we're just gonna check if the stack is empty or not. So if the stack is empty, then we're just gonna print stack underflow and we're gonna return. Otherwise, first of all we're gonna get the top value from the main stack and we're gonna store in the variable popped, and then we're gonna reduce the top pointer, and then we're gonna return the popped value. So reducing the top pointer means, so suppose the top pointer is pointing to this level, and here also we have the top pointer pointing to this level. Now if we are reducing the top by 1, that means the top in the main stack will go down, and also the top in the min stack will also go down. So this way we are effectively removing the top element in both the stack. So that is in case of the pop operation. And also we have the pick operation. So first of all, we're gonna check if the stack is empty or not. So if the stack is not empty, in that case we're just gonna return the top value of our main stack. So that means we're gonna return the top value from the main stack. And also we have this getMin function. So this function will return the minimum value. So first of all, we're gonna check if the stack is empty or not. If the stack is empty, then we're gonna print stack is empty, and then we're gonna return. Otherwise, we're gonna return the minStack.top value. That means we're gonna return the minStack's top value, because this is the minimum value in this level. So this way we can perform all the stack operations. So now inside the main method, first of all, let's just push the value 5. Then we're gonna push the value 2, then 8, then we're gonna push 1, and then the value 10. So we have pushed the value 5, 2, 8, 1, and also we have pushed the value 10. So that means whenever we push the value 1, so 1 will be pushed in the main stack, and also the minimum value also 1, so that will also be pushed in the min stack, and the top pointer will point to this new top element. And also if we push the value 10, then the 10 will be pushed in the main stack, but the minimum of 10 and 1 is 1, so 1 will be pushed in the min stack, and the top pointers will point to these new values. So here we're gonna call the getMin function to get the minimum value. So here now if we call the getMin function to get the minimum value, so this function will return the minStack.top value. So that means it should return the value 1. So you can see the minimum value is 1. So here let's now pop some value. So we're gonna call the pop function. So here we're calling the pop function. So the pop function will remove the top from the main stack and also from the min stack, and it will return the minStack.top value. So that means these two values will be popped, and we should get 10 in return. So you can see we're getting the value 10 in return, and the top elements in both the stacks will be removed, and the top will be modified in both the stacks. Now let's just call the getMin function again. So now if we call the getMin function again, so it will return the minStack.top value. So we should get the output 1. So here we're again getting the minimum value as 1. So let's just perform the pop again to remove the top values in both the stack. So this pop function will remove the top values in both the stacks, and then it will return the minStack.top value. So it should return the value 1. So here if we call the pop function again, so you can see we're getting the output 1 again. So the value 1 is coming from this main stack. So because these values are removed, so the top pointer will be updated. Now again we can call the getMin function to get the minimum value. So the function will return the minStack.top value, so it should return the value 2. So here we're gonna call the getMin function again. So this time we're getting the min value as 2. So that means our function is working properly. So this way we can use the min stack and we can get the minimum value in constant time. So hope you understand the concept. See you in the next one. Take care.